Hi, folks. I think the title on the agenda is actually slightly wrong. I think that was the working title that got put forwards. We're actually going to talk about domain-driven design today. Sorry if that's disappointing, but on the plus side, it is going to touch on insurance because we're an insurance company. So let's start with the proposition. And it's this: if you thought about it long enough, you would invent domain-driven design. So Eric Evans' book on domain-driven design was published in 2003, so a couple of years after I started writing software. But as with many good things, I didn't discover it until probably about 10 years later, something like that. And by that time, I'd been spent a lot of time writing software, thinking about software, and so I'd kind of invented quite a large part of domain-driven design myself, but in an ad hoc, informally specified, bug-ridden kind of way. What I thought might make an interesting talk is most domain-driven design literature starts from the domain-driven design concepts and shows how you'd apply them to software. And I thought, well, rather than doing that, why not repeat my journey in a rather shorter time than 10 years and start from nothing, just start thinking about writing software and writing software well, and see if we can derive a lot of the domain-driven design rules. So that's what this talk's about. Should be about 20, 25 minutes, something along those lines. Okay, so where we'll start is with the insurance domain. And by domain, what we really mean is it's kind of the industry you're in. So this might be banking, it might be food delivery. In Zego's case, it's insurance, commercial motor insurance. And so our domain here is, we're going to do a quite simplified one. We're just going to talk about a policy and a person. In reality, the domain is a lot more complex than that because insurance is a 400-year-old industry, so it's actually incredibly complex. But this is all we really need to drive quite a lot of domain-driven design. So when I'm starting to think about domains, the first thing I tend to look at is information flow. And when we think about these two things, a person can exist without a policy because when you're born, you don't have an insurance policy, whereas a policy cannot exist without a person. So, because a policy needs to have a policyholder, and they don't always have to be a person. Sometimes they can be a company or something else, but even those have to be people. So ultimately, a policy needs to be aware of a person. And bear in mind, this isn't any kind of relationship diagram. This is just the information flow. This is who needs to be aware of what. And so already, just by thinking about our information flow, we've invented layering. Because a policy is aware of a person, but a person is not aware of a policy, we can say that person is lower level than a policy. It's more fundamental. So a policy sits above it in terms of layers. Now, I know what you're thinking. This is not a DDD specific concept. This is actually pretty common in software, but it is a foundational common concept. And so it's kind of worth thinking about all the concepts that we're actually inventing today. Okay, so what if we did turn this into a relationship diagram? Because this is probably intuitively what you'd say. A policy has a policyholder, the policyholder is a person, and therefore this is what our relationship diagram looks like. And this isn't just a hypothetical theory. This is actually what things looked like at the start of Zego, because if you just go straight into it, that's what it might look like. But as soon as we get into this, once we start thinking about the business domain, we start running into problems like what happens if a person changes their name? And we immediately run into the problem that this breaks regulatory requirements because a policy is a contract. And so you can't just implicitly change it. Contracts have to be changed explicitly with agreement from the people involved. So if a person changes their name and a policy is just linked to that person, then the policyholder name got implicitly changed. So we're kind of going against the regulations already. Now you could start to think, well, we could solve this by using versioning of the person. So policy points at version 1, and then we explicitly list it to version 2. And that could work. But then we start to run into other problems as well with this approach, is that we've got inconsistent data semantics. And because our policy models change in state over time, if a name changes, then until that point on the policy, the name would be one thing. After that point, it would be another thing. So we actually need to track before and after. The other problem we've got is that then things like email and phone number actually aren't relevant to a policy. If you change your email or if you change your phone number and you don't tell your insurance provider, it doesn't affect the validity of your insurance policy in the same way that changing your name would. So actually, we don't care about these things. from a point of view of a policy. And we also always need the latest version, because if you've changed your phone number 3 months ago and we try and phone you on that, then someone else is going to answer. So we've got 2 problems already just with our naive model. So the solution to this: separate models. We model what we actually want in each of these areas. So the person still looks like a person, but our policyholder just has a reference to which person it is. The name, which we can simplify, because actually on a policy all we care about is the legal name. So we just need to print your full name on the document. We don't care about the difficulties of first and last names, and the birth dates. So we can totally remove email and phone number as well. And one of the first things you might notice here is that we're copying data. One of people's gut reactions to copying data is, oh, well, that's bad. You should only have one copy of the data. But actually here we've established that just by starting to think about how things work in the real world, we should have a copy of data, because one represents you, the person. One represents what a policyholder looks like on a policy at a certain point in time. So we've got our modified relationship diagram as a result of that. A policy has a policyholder, which is aware of a person. And now when a person name changes, the policyholder name does not change. So we're no longer violating the regulations. And this looks much like we'd actually want in the real world. Now, of course, this introduces a problem that when a person changes their name, it doesn't update the policyholder's name. And that is a problem because now we've broken part of the requirements of the real world. So we'll come back and fix that. But before we do, there we go. So that's an interesting thing, is we've invented a lot of the core principles of domain-driven design. So the key thing is here, we took these things and we called them relationship diagrams, but they're really domain models. And what we've done here is we've understood the real-world domain and modeled it as a domain model. So now if there's only one slide from this talk that you remember, one principle, make it this one, because this is really the core of good software design and domain-driven design, is understand the real world and model it. Everything else we're talking about just supports this, moving from obvious but incorrect models to less obvious but correct models. And when we did this, interestingly, as we didn't create one domain model, we actually created 2 domain models, because we've got this people domain model, which just contains a person. And we've got this policies domain model, which has a policy and a policyholder. And they're not actually linked, apart from the policyholder just has an identifier of a person. So this people domain is completely separate and could be external. It doesn't even have to be our own software. So we've actually simplified, if we're thinking about just about people or just about policies, that we only have to think about a smaller area. And we've invented bounded contexts. That's all this is, separating it into smaller parts. And each one is internally consistent, but not necessarily, as we've seen, consistent with each other, because at the moment, person, when it changes, will not be consistent with the policy's context. Okay. And these different contexts are authoritative about different things. So we can ask them different questions, like if we want to know about a person, we ask the people context, what's the phone number of the person with this identifier? In the policies context, we ask quite different questions, like what cover did this policyholder have on a particular date? And here we already start to notice something as well about language. So in the people context, we still use the word person to refer to a person. But in the policies context, we're no longer using the word person. Actually, we have to qualify it with a role, such as policyholder or name driver or something else like that. So although the policies context is aware of a person, that word doesn't really have any meaning there. And similarly, in the people context, we might say, well, the word policy has no meaning, but actually it might have a different meaning. So policy in there could refer to something like an authorization policy if we considered security as part of the people context. So policy might mean something completely different to insurance policy in a different context. And this is a really important thing. And you'll notice this also matches the real world. If you talk to people in different departments around your company, they'll notice they use the same word to mean different things, because that's kind of relates to their subdomain of the business. And so here, we just invented another concept, ubiquitous language. And ubiquitous language is that concept of within a context having a language that is consistent. Sorry. Ubiquitous language, I think, is a really bad name. When people hear ubiquitous language, they kind of think ubiquitous should be ubiquitous, as in covering the whole business. But it's not. It's ubiquitous to within a particular context. Oh, and we've invented some other things as well. So when we looked at our person, we thought, well, if you change your first name or your last name, you're still the same person. If you change your birth date, well, you probably can't change your birth date. And if you change your email or your phone number, all of these things, they can change, but you are still the same person in the real world. Now in software, we can't represent the concept of you effectively. So what we tend to do is pick some kind of surrogate key, like an ID, maybe a UUID, that kind of thing. And we say, right, anything with that UUID is you, regardless of any other changes made to the data. And so we've invented entities. Entity, you hear the word thrown around a lot. This is a more formal definition of an entity is anything identified by one or more unique keys. What about policyholders, though? Is this an entity? So it doesn't have an ID. It refers to a person ID, but it doesn't have its own ID. It has a name. It has a birth date. So if these change, if any of these things, person ID, name, or birth date change, then this whole object changes. We can't recognize it as being the same object. So any two objects with the same values are logically the same. Any two objects with different values are logically different. And this, again, actually is what we want, looking at our real world, is that because policies are adjusted separately, if you have two policies, then we would just adjust one and adjust the other. So actually, we want them to be different, rather than being a single whole policyholder referenced by an ID. And so we've just invented another concept here, value objects, which is a thing defined only by its value. And these aren't new to use them every day. UIDs, strings, dates are also value objects, because if they're different, it's a different object. Okay, so that's some of the core concepts. Let's get back onto this name change. So what we might think is, okay, we've changed the person's name. We now need to go and adjust that policyholder. And the problem with this is it's semantically wrong. When we talk about adjusting a policy in the real world, not adjusting a policyholder. So this language we use, the way we think about the real world, should already guide us to, this doesn't feel right. And quite apart from that, we run into the practical consideration of if you adjust a policyholder, then you might make the policy invalid. So, let's say, for example, your date of birth had been entered incorrectly and it said you were 18 years old. And then we actually had to correct it, and it turns out you were 17. Perhaps you've been sold an insurance product that's only valid for people over 18. So if we could reach into a policy and adjust a part of it, we might have made the whole thing invalid. Okay, so let's try again. Another intuitive answer. When a person changes, we'll adjust the policy itself. But this causes problems as well. So first of all, we've already said our layered architecture means that policy sits above people, and people don't need to know about policies. But here, a person does, because if you have to adjust all the policies that you own, we need to replicate policies into the people domain, which means we've now not only got complicated the people domain, but we've got a synchronization problem. And even worse, we've created a cycle. Now, if you've done much work with relational databases, you probably run into cyclic problems like record A reference with foreign keys. Record A references B, B references C, C references A, and you want to delete them, but you can't delete any of them because of the cycle. So cycles complicate programming. So it's something we want to avoid. So it's both semantically wrong and difficult. So what can we do? Well, what if we broadcast information? So instead of actually adjusting the policy, we just say, hey, I've changed. Here's an event. Now, we're no longer violating layers because this event lives purely in the people context. And then policy can subscribe to it. And so we can see that the information flow remains top to bottom. Policies depend solely on people. People still has no knowledge of policies. And the great thing is, by taking this approach, we've not only cleaned up our code and made it more simpler, we've made it more flexible, because now other people can subscribe to this person changed event or other tools. And this is really useful for things like, for example, populating data lakes or data warehouses. And because you get change notifications about every change, it lets you build things like slowly changing dimensions. So it's a really powerful way to replicate data into other places where you need to see it as well. And this is domain events. We just invented domain events. Again, if like value objects, if like these other things you're thinking, well, I've used events before, that's kind of my point, that as you go along and you write software, even if you're not aware of domain-driven design, you will gradually invent the concepts as you get better at designing software. Okay, so what does our domain event look like? Well, typically you've got 3 bits of information. When did it happen? What happened? So usual CRUD action, created, updated, deleted, or perhaps something else. And what data is associated with that event? Typically, the new state of the entity itself. So let's see how we handle it. We'll dive back into a little bit of code here. Let's assume in our policy, we've got a method to adjust the policyholder, which takes the new policyholder and since when that's taken effect. So we can add a handle method for this, which handles the person changed event. And the first thing we're going to want to do is convert the person on that event into a policyholder, because our policy needs a policyholder, not a person. So that's a fairly simple thing to do here. Might be more complex with dealing with names and so on, but that's the gist of it. And the next thing we do, we're going to find all the relevant policyholders and adjust each of them. And again, in the real world, this is going to be more complex because we're going to have to deal with failure. We're going to have to deal with things crashing halfway through the loop, all that kind of thing. But essentially, that's the gist of it. Convert from the people domain into the policies domain, find the policies, perform the relevant action on them. But we've got a problem here, because we've already kind of tried to separate our models and say people and policies are separate models, apart from perhaps identifiers linking to each other. But with this person changed event, we've leaked our people model into the policies model, which is now this is increased coupling, and it's given the policy more than one reason to change, because if the person model changes, this policy model now has to change as well. So this breaks the single responsibility principle. And I know we said we'd go from first principles on this talks, and I'm kind of introducing the single responsibility principle here, but I think that's such a fundamental principle that I'm going to feel like that's a reasonable thing to do. So what can we do here? And we can actually make a one-line change and fix everything. So we just introduce a person listener class. And this now no longer exists in the policy domain model. It's still not in the people domain model. And we've got this component that essentially has a single purpose of bridging the domains for this particular type of change to a person. So now all the domains are separate, internally consistent, and we've got a component that sticks to the SRP that bridges them. And this is what our updated relationship diagram looks like. So not everything in domain-driven design is about the domain model. We've got these things that take multiple domain models which work in isolation, but then they make the whole insurance application work by linking them together. And so what we've done here is we've invented application services. Okay, and by this point, we've really invented quite a lot of domain-driven design. So just by reasoning about this tiny domain with 2 entities, we've invented layering, domain models, bounded context, ubiquitous language entities, value objects, domain events, and application services. And hopefully what I managed to show in this is that these things are not concepts that we read in a book and force into our design. These are things that by thinking about good design, they fall out of it. And that's going to lead me to make a bold statement, which is that domain-driven design is an intrinsic property of well-architected systems. And just to be really clear on that, what I mean is that systems that are well-architected will implement domain-driven design principles, even if perhaps the people implementing didn't know them as such. And the systems that don't align design with the domain-driven system, so DDD principles, are probably not well-architected. Now, well-architected is a big area, but the kind of thing I mean by well-architected is that you can evolve the system without destabilizing core components. It's extensible, so you can add functionality without changing things all over the place, that you can introduce reliability boundaries and things like that, which is where events let you do, you can start putting reliability boundaries in there. And so the point being here that if domain-driven design is an intrinsic property of well-architected systems, it's not optional. You only really have two choices. You can either do what I did, which is spend 10 years inventing it yourself and then finally read the books and get better at it, or you can save yourself 10 years and read the books. This is the approach I'd recommend, just to be clear. So of these books, Domain Modeling Made Functional is probably the one I'd recommend starting with. I think it gives a really compelling use case for why domain-driven design is so good. And it shows how well it works with functional programming. Most of the DDD literature is actually dealing with object orientation. I personally find it better with functional programming. And this is one of two books that I think every engineer should read. Domain Modeling Made Functional. The other one is Designing Data-Intensive Applications. These other two books, much more in-depth treaty of domain-driven design. A little bit cringy, I've got to say, in places. But they do give a much more thorough treatment, and particularly in implementing domain-driven design, it starts getting into other patterns that are quite closely associated with it, such as hexagonal architecture. And I'm not sure can't remember if it goes into event sourcing, but again, event sourcing is something that's quite closely linked to DDD. So it starts giving you not only the domain-driven design knowledge, but other avenues into other patterns to hang that knowledge off. And so that's the end of the talk. Thanks for listening. I hope that was useful.
Thanks, Greg. I was just saying lots about domain-driven design there, which was not a familiar subject for me before. So yeah, thank you for that. We have had quite a few questions come through, so I'm going to fire some away at you, if that is okay.
No problem at all.
One of the first questions that has come through is, how is Zego doing innovation differently to other or similar organisations? It's a good one.
I suppose probably in the insurance domain, a lot of it's really about being data driven. So most insurance is, I'm trying to find a nice way of saying this, not very smart. So it's mostly based on quite simple algorithms that are based on the idea of an idealized person. So, maybe they're 25, they live in a particular postcode, they drive a particular type of car, and then it gets adjusted if you're older or younger, if your car is higher or lower insurance group, higher or lower value, lots of things like that. And it kind of all gets multiplied together and comes out with a number, and then gets adjusted quite significantly based on what other insurers are doing. So Zego is trying to change that by moving away from who you are and where you live to your behavior, like how you drive. So things like what time of day, using telematics to see how you do harsh braking events, how do you corner, do you accelerate, things like that. So it's try and detect, and so it's not just these things. Then we try and map this to, are you breaking the speed limit? Are you driving in an appropriate way? So really trying to make insurance fairer, and hopefully try and get a better price for better drivers. But not only try and get a better price for better drivers, also trying to expose that behavior. So if we're seeing this kind of behavior, then as we get kind of further on in this, it's like, here are things we think you could do to improve your driving and therefore get better prices.
Okay. This actually leads quite nicely on to another question which we've been asked about. What do you like most about working in insurtech? And I suppose just a question from me is, is it an industry you were familiar with before joining Zego?
So no, I wasn't familiar with the industry. I mean, I was loosely familiar with Zego because I was at Deliveroo for 5 years before Zego, and so Zego's founders were also ex-Deliveroo, so I knew quite a few people there, and their initial insurance product was primarily insuring Deliveroo drivers. That's kind of where the company came from. So I was loosely familiar with the company and the kind of thing they did, but not with insurance at all, no. What's best about it? I mean, perhaps one of the most surprising things is it's actually very interesting. I think when I first started talking to Zego about working there, I don't think there's many people who would go to an insurtech and think, wow, that sounds super interesting. Isn't insurance like a fascinating subject? But actually it really is. It's so complex because it's evolved over 400 years, and it's not evolved according to any sensible rules. It's just kind of evolved organically. It's the amount of things you have to understand. Like if you're like me and you really like to understand very complex subjects and think about how to model them sensibly and how to make them kind of usable for people, then it's a really interesting area to work in. But it's also a bunch of great people. Like, I mean, domain-driven design is one of the philosophies I think we all share. And that's actually really enabled us to try and do things better and design things better and design systems cohesively and design a sensible event-driven architecture and do things like populating our data warehouse from event streams and things like that. So it's a mixture of the domain is interesting, but actually the way we're approaching technology I also think is quite interesting.
Nice. Okay, so it's a mixture of people.
Yeah.
We've actually had a question on GDD itself. So do you run into design patterns in GDD? Is a question somebody has asked.
So do you write design patterns in DDD?
Do you run into design patterns?
Do you run into design patterns? I mean, I guess you kind of. I mean, design patterns is perhaps a loaded term. Yeah. So I always think of design patterns as really being things that work around deficiencies in your language or infrastructure or anything like that. Because if it was sufficient, then you probably wouldn't need design patterns. I mean, DDD does absolutely have design patterns. So, I mean, we've seen things like one of the last things we saw there was listeners, for example. That's kind of a pattern, I guess you could argue. Publishing events is patterns, application services patterns. So I guess it's all design patterns, but I think it's probably better patterns than some that you might think of, like singleton patterns and so on like that, which are probably not good ones. These are patterns that help you think about structuring software.
Right. We've got a few more technical questions coming through. I think now we're on the subject. Somebody has asked, are you using microservices? And do you have multiple domains on the same microservice?
Yeah, we're building a service architecture. I don't know whether I'd call it microservices. Microservices means different things to different people. Like you look at the way some companies do things and they've got 1,500 services with 10 services per engineer. We're not doing that. We're basically trying to stick to cohesive boundaries. What we're tending to find, roughly speaking, I think, is that services are essentially oriented around an entity. So, things like we have a service for vehicles, which deals with all things like looking up vehicles from government databases. I mean, I know a vehicle doesn't sound very complex, but it's actually surprising how complex a service just dealing with vehicles is when you insure them. We have a service that deals with the state of policies. And this, is quite a large service with quite a lot of code because it deals with a very complex area, but that's still a single service. So we're not sort of aiming for a particular service size. We're aiming for kind of a sensible architecture with boundaries defined by the domains. So no, because we've been able to, it's relatively greenfield as we built the new platform. We haven't had to run into that compromise where we've got many domains or things smashed into the same thing. We're able to, if you're a bit more familiar with DDD, we're kind of able to align our bounded context with subdomains, which is a nice thing. Of course, we do still run a lot of code on our monolith, which is how Zego started. So in there, yes, there's a lot of stuff smashed together, which is one of the reasons we're building a new platform.
I suppose that's one of the nice things, isn't it, about working on a greenfield project is you really are building it from scratch. So, you can be as creative as you like with what you're doing. Somebody has asked just about the way that you work at Zego. So how collaborative is the work in your engineering teams? I suppose just to elaborate on that, how are things structured in terms of the teams at Zego as well?
Sure, yeah. So essentially, what we're aiming for, and this isn't quite the way it is everywhere because hiring is difficult. I should mention we are hiring. If any of this sounds interesting, is where we're trying to get to is to the point where we've got tech lead and product manager in each squad, along with engineering manager either for that squad or for a couple of things, and potentially scrum masters depending on what the teams need to run. But teams are essentially cross-functional, so we're trying to make sure they've got all the right people they need to be able to deliver within the constraints of hiring. So that's kind of the team structure. And then above that, we have sort of, I guess, hierarchy of assistants. So we have staff engineers who'll be working with a couple of teams and helping them define their architecture and think about patterns. And then we have people like me, principal engineers, which are working across departments and talking to a number of staff engineers. But I think one of the really key things is that what we want to do is enable people. So in a lot of companies, this is top down. So, features are specified top down, architecture is specified top down. And what we want to do is do it bottom up, because there's no point hiring lots of good people and then telling them what to do. So, people like, so things like my role, the staff engineer role, is an advisory role. We help teams with architecture, we help them think through problems, we share what other teams are doing, because we have more visibility. But it's not a dictatorial thing. And if there's a disagreement, ultimately the teams are the ones that win. So it's that kind of thing of team-oriented, cross-functional with support structure.
Nice. So it's almost a little bit of kind of flat hierarchy, giving everyone the same opportunities, I suppose, within the business.
So it's kind of like, there is a hierarchy, obviously. I think and I think it's important to have a hierarchy, because you hear about companies like Valve was one of the famous ones that said, we're a totally flat hierarchy, everyone is equal. And the problem is, if you have no hierarchy, no official hierarchy, what you have is an unofficial hierarchy. And I think that's far more harmful. It's better to be explicit about it.
Yeah, definitely. We've actually had a question just about the tech community. And it sounds like, obviously, coming from Deliveroo and I guess, having those contacts to move into Zego. Somebody has asked, in your career, how important has the tech community been for you personally?
I suppose probably in terms of the wider tech community, so things like people I've met through conferences and stuff like that. This is probably an awful answer to give at a conference, but probably not that important. But in terms of people I've met through my career, incredibly important. So I've never changed jobs by applying to jobs. I've only ever changed jobs just through contacts I've known, people I've met, people I've talked to. So people you meet at work, I think, is hugely important. Now, this is not to say that other people might not meet people through conferences or things like that. So, and so I think from that point of view, getting jobs is probably best through the people you know, because you can find a lot more about the company. And actually, the other way around is also true. That people you hire from referrals tend to be better. They tend to be higher performing. They tend to stay at the company longer. And this is something I've both observed and which there's a lot of evidence in the industry to support that's actually true generally as well.
Yeah. On the topic of Zego growing, and you've mentioned hiring a couple of times, I guess what might be interesting for engineers just to understand is a little bit about your tech stack and the technologies that you use, or what you might be using in the future as well.
Sure, absolutely. So in terms of languages, Zego was originally a Python shop, Python Django monolith, which is still where a lot of things run. We now use Python and Scala. So many of the new services are written in Scala, and some of the new ones are also written in Python. So these are basically two implementation languages that people can pick from, whichever fits the scenario best. There's no hierarchy between the two languages. In terms of other things, so we're doing data streaming. It's mostly Kinesis. It's advanced quite a long way now. We're on AWS, so Kinesis advanced quite a long way. We looked at things like Kafka, but Kinesis is now honestly close enough in most ways, and it's so much easier to manage that we can get away with things like that. Data storage, mixture of Postgres for a lot of things, Dynamo in some areas. All our inter-service stuff is protobuf definitions, which is all the events, so contractual events, and gRPC between services. What else is interesting in the tech stack? I should talk about front end. Sorry, front end is not my thing. We're using, I believe, React and Next.js, if that means anything to anybody.
I'm sure it does mean something to a few. We've actually had, I suppose this might be the final question. It's quite an interesting one. You mentioned some of the DevOps tooling then. So why do you think that DevOps has gained prominence over the last few years?
Good question. I think it's because it's a really important area. So if you ask me what's the most important area to get right, it's CI/CD build deployment, because it really comes down to risk. Like, all software development ultimately is about risk, and the lower the risk is, the faster you can move. And so if we look at the DevOps space as being able to mitigate risk by being able to build faster, deploy faster, repeatable things. So, for example, even things like disaster recovery, like being able to rebuild your. We run on Kubernetes. That's maybe another tech thing if people are interested. So things like being able to rebuild your Kubernetes cluster in the event of disaster. So things like we're moving to GitOps for that, because then we can define the state of our cluster in Git and literally bring up new clusters just from that, rather than having the perhaps the more traditional build, deploy, and then the deployment process actually puts it in there. So it's not an area that I'm hugely knowledgeable about. We have much better people than me work in this area, but I think it's the most fundamental area to get right, because if you can deploy, if you can roll back, if you can do green blue deploys, if you can do canaries, getting feature flags and stuff right to separate release from deploy, then you're in a place where you can move really fast, because you don't have the risk of any of those things. Like if you only deploy every 2 weeks, deployments are hugely risky. So yeah, that's probably that. That's why it's gained prominence, because it's incredibly important.
Yeah, that's a good answer. Just one final question from me is what do you think you're most excited about in terms of the direction that Zego is going in, and the projects that you've got upcoming as well?
Honestly, I think I'm quite excited by a lot of things. So I'm quite excited by, we're currently going through our OKR process, and I'm quite excited by that, because that's we're kind of getting better at this mechanism I talked about of kind of delegating authority to teams. We're not as good as we should be, and we're getting there. Some of the projects we've got going on, like pricing engines and kind of using ML models to kind of predict kind of pricing factors that other people in the industry just can't use, I think is really interesting. The data streaming architecture is really interesting, and some of the stuff we're doing there, like being able to automatically pick up changes to events and automatically put data in the warehouse without having to know anything up front about any events that get published, is great. There's just lots of really interesting stuff going on.